Good morning, good afternoon, good evening. Hello, everybody. Thank you so much for joining us live here today on Serverless Office Hours. I'm super duper happy to have the one, the only Vida Raman joining us. Vida, how are you today?
I'm doing good, Julian. How are you? Thank you.
Excellent. So, you're an AI ML specialist. First of all, that sounds like a super cool title, but I know you've been at AWS for a while and you've done some things beforehand. So, what's been your journey to AWS and what has sort of piqued your interest and made you jump on the AI ML train, so to speak?
Sure, Julian. So I've been a developer at heart. Even before I joined AWS, I was a developer and I used to do file system development back then. And after I joined AWS, because of my developer background, I joined the serverless specialist SA team, and I was a serverless solutions architect before coming into AIML. And then when I was doing serverless and helping customers with serverless deployments and serverless architectures, I saw a lot of customers were using Lambda and other serverless services to deploy machine learning models into their machine learning endpoints. And so I started working on their machine learning needs using serverless, and then that got me interested into machine learning. And I thought, hey, um, you know, let's jump into the other end of the spectrum and see what machine learning is about. And I joined the ML Solutions Architect team. And now I think building machine learning and generative AI applications using serverless is the way to go. And I love talking about both of these domains.
Cool. Well, yeah, I think you've picked the right year to jump in on generative AI and AI in general. I know you did the move before the whole sort of Gen AI thing happen. So yeah, excellent for peeking into the future and picking the cool things to talk about. And yeah, I think that's what we're going to be covering a little bit later today. And
Yeah.
serverless is such a great way to consume all of these AI models, which are available in a serverless way. But just before we get back to Vida, and don't forget that what a silly thing. Don't forget to say, we're live on Serverless Office Hours, so send us your questions, send us your comments, tell us where you're even from. It's really cool to hear what's going on in your world as well. But just looking back on the previous world of serverless, last week we had super serverless Lars Jacobson talking to colleague Dave Boyne, and on the 17th of October, all about a whole bunch of tools that he's written, and one being SAMP CLI, which is just augment SAM with a whole bunch of cool utilities and a whole bunch of different things. So that is on the Serverless Land YouTube channel, youtube.com/serverlessland, along with all of our previous Serverless Office Hours episodes. In terms of what's new in the world of serverless, just things going on. Obviously, reInvent's coming around the corner, so who knows? There may be some more interesting, exciting things. So just sort of looking at the top two, in fact, EventBridge has MSK has now got EventBridge Pipes console integration. So this is just a way that if you're on the actual Amazon MSK, which is all about Kafka, managed service for managed streaming Kafka, then you'll be able to connect to EventBridge directly from there. And also from Lambda, if you're working on IPv6, so outbound connectivity from or via a VPC, you can now use IPv6. So that is super duper cool if that is something that's going to help you. And just some recent compute blog posts that, in case you missed it for Q3, Ben on my team has put this all together, and that's literally just a recap of the Q3 2023, all the blog posts and releases and videos and talks, and you'll actually be amazed looking through it to see how many really cool avenues to explore content from Marsha Bishaba on our team as well, with all their Spanish content and their podcasts, and there's just loads. So it's a really easy way to catch up with what's been going on. And then some other blog posts talking about technical kind of things. The second one down, EventBridge wildcard pattern filtering. So a really good post by Rajiv and Brian talking about how you can use that. So, for example, if you're doing, I think the example they used in their blog post is using is looking for pattern matching for files from S3, and you can obviously look for JPEGs or doc files and do a whole bunch of things with the wildcard patterns. And then a document chat with Pascal and Martin talking about Lambda and Bedrock, something similar we're going to be talking about today. EDA Day is in Nashville, which is literally in 2 days' time. I'm actually in Nashville at the moment, so that's why it looks a little bit strange. I'm in the office as well. And Vida, I know you're going to be in Nashville, so looking forward to catching up when you get here. And Nashville is a cool city, really cool city. Obviously, one of the centers of music for American music. And yeah, it's just a cool place to come around. And there are actually only a handful of tickets available. So if you do fancy popping over to Nashville for Thursday to see for EDA Day, Whole bunch of great talks. James Oakart is doing the keynote session in the morning. There are going to be workshops. There are going to be talks from a whole bunch of different people talking about EDA. So yeah, really going to be a good day, super useful. And Nashville, from what this is my first time here, Nashville is a super cool time. So a super cool town. So we'd love to see you over here. Obviously, the big show at the end of the year is reInvent. So reInvent, we're all of us, a lot of people are going to be there. So that is when's it? November the 27th to December the 1st. If you haven't got your tickets, I would suggest you sort that out. And yeah, thank you, Matthew Bonig, CDK Guru. So cool to join you from Colorado. Thanks for joining us. And also, Daniel Medina Casino. Thanks for joining us via LinkedIn or from Colombia. So we've got Colorado and Colombia. But for now, wrong screen to kick on. That's the other thing I was going to talk about. The serverlessland.com learn page. So much great information over here. There are guides and workshops, and you can search by services and categories and things like that. A really good place to be able to learn all about all things AWS. Serverless. But this week, we're talking building GenAI apps with serverless. So Vida, obviously GenAI has been doing huge mind share this year, all about things. Tell us, what should we know about GenAI apps and how it relates to serverless?
Yeah, I think generative AI has been this year's theme. We've seen a lot of customers who have not used machine learning before want to use generative AI because they want to differentiate their business. So I'm here to talk about what is generative AI, right? And how can you get started using generative AI? And how can you develop applications using generative AI, and why you should use serverless to build generative AI applications. So I can go pop up my deck and
bring it up.
About it, and then I'm gonna walk you through a demo.
Sounds great. Sounds great. Yeah, share your screen and I'll pop it up.
All right.
There we go. Excellent. We're up.
Awesome. Oops. Give me a moment here.
That's quite all right. Anything roundy with PowerPoints and getting it up working is hard enough. I know exactly how you feel.
All right, so I'm going to dive a little bit deeper into what generative AI is. How is it different from our traditional machine learning models? Why it's being so popular this year, and how you can get started to build applications using generative AI, right? So machine learning is not new. We've seen this paradigm shift, right, over the last several decades. Um, but I believe that we are at an inflection point right now with respect to machine learning. We have seen customers use more and more customers use machine learning to differentiate their businesses. But with generative AI, which has captured everyone's attention and imagination, we are seeing that paradigm shift even more. And I believe that every customer experience going forward and every application that will be built going forward is going to be reinvented to use generative AI. Right. And the key drivers that I see for this kind of explosive growth in generative AI is three factors. One is the compute capacity, the readily available compute capacity at scale to train these models, generative AI models, which are really huge. The second is the data growth, the digital proliferation of the amount of data, and the amount of data required to train these models is huge, right? And the third is over the years, we've built that model sophistication, the model architecture itself, the machine learning model architecture itself is becoming more and more sophisticated due to research being poured into this. So it can do things that it would not do before, right?
Yeah.
So with that, let me introduce what generative AI really is. Generative AI is a class of AI that can generate new content. Generated content is very, very close to what a human would generate, right? So that's why it's being so popular. It's like you cannot really distinguish between human generated content and a machine learning model generated content. That is how close it is to acting like a human. The second is it's powered by these large machine learning models called foundation models. And these foundation models are pre trained on large amounts of data. Imagine trillions of tokens of data. And these machine learning models are so huge, they have several hundreds of billions of parameters in them. And what are these parameters? When I say machine learning model has parameters, these parameters are model specific um, um, parameters that can store information and process and pass information, right? So these are integral to how the machine learning models work or the generative AI models work. And more the number of parameters, the more the capabilities it has, right? And it is applicable to many different use cases like text summarization, question answering. You can even create digital arts with this and even use it for create generating code. And a lot of developers are using this currently to generate code and be more productive. And the good thing about these generative AI models are they can be customized for specific domains with very minimal effort. That would not be there before. I mean, before the amount of training required to customize these machine learning models to your own domain was a little significant. So that has reduced significantly now with generative AI.
So is that the difference of sort of using the foundation model and then adding additional information onto the foundation model, which is then specific to your domain, or how does that work? Are they separate sort of separate ways they work? How does one actually customize it for the specific domains, but still use the foundation models?
Yeah, there are a couple different techniques how you would customize this to your specific domain. And I'm going to talk about one of those techniques and show a demo. One is you can use it, you can provide it information from your domain in natural language and ask it to answer based on your data, right? So
Okay.
that's purely through prompt construction and prompt engineering and give it the data and say, okay, please read this and then give me an answer to my question. That's one way to do it. Another way would be to what is called fine tuning, where you are using techniques like what is called performance efficient fine tuning, where you're only taking maybe the last layer of the model architecture or adding what is called adapters to this model architectures and only fine tuning that layer so that you're not retraining the entire model, which will take a long time and it is not very efficient for you. So the fine tuning is significantly lower cost and faster, and so you're able to take that just a layer and then fine tune that layer and make it adapt to your specific domain. So there
Okay.
are a couple different ways to do it. So what are these generative AI, models being used for? And what are the use cases that we are seeing with customers this year? We're seeing mainly, in enhancing customer experience through chatbots. Yeah, chatbots existed earlier. There were chatbots, if you go to any website, and there were chatbots that would help you navigate. But with the use of generative AI as the backend to these chatbots, you are adding much more, enhanced customer experience. It's like a human sitting behind and answering all of your questions, right? So that's a much more better customer experience, and it's a delight to your customers as well. And we're also seeing, more and more organizations building what is called virtual assistants. Not only is the chatbot able to answer your questions, but also take actions for you. Right? Imagine you telling a virtual assistant saying, "Hey, go, figure out what kind of tires I need for my car, and then order those tires, and then also create an appointment for me to change those tires in my car." Right? So the virtual assistant is literally sitting there and performing all of these actions for you, and you're just telling it through voice, and it can take actions for you. Significantly reduces my burden and also increases my productivity. Right? So that's what a lot of customers are building. The next area where we see a lot of use cases is organizations building conversational search engines for to boost their employee productivity, making their employees' lives easier. And also developers use these generative AI models to generate code and significantly improve their productivity as well. Right. And in the content and the creation and the creativity space, we are seeing more and more customers are using these to create new content, be it design and modeling and so on. And also some to improve some business operations like intelligent document processing, optimizing processes, business processes, and so on. So I'll dive a little deeper into how the generative AI models work and why it's different now. So as I said earlier, generative AI itself is not new. We used to have all of these tasks that traditional machine learning models would perform, right? Like we had what is called the BERT model for text generation, summarization, question answering. You could take that model and fine tune that to perform those tasks. We had services like Amazon Transcribe and Whisper to do transcription, transcribe audio to text. Services like Amazon Translate, which would perform translation. And also in the artificial human speech space, you have Alexa and Siri and Polly, which are able to convert speech to text and text to speech, right? And also like search engines. We all know that our AI powered search engines already exist. But what is different with generative AI and why is it so popular? Right? The difference is that in the traditional ML model space, what customers did was, they would take labeled data sets, and for each task, like say for example, you want to do a text generation or you want to do summarization of documents. For each task, you would have to start with labeled data sets, take those data sets and then build a machine learning model from scratch or fine tune an existing model, and then create that machine learning model which could only perform that task, right? But with the foundation models, or the generative AI models, what is happening here is we are taking unlabeled data sets, and this is huge amounts of data in the order of trillions of tokens or trillions of words, right? And take that unlabeled data sets and build the machine learning model, which is the foundation model. And this machine learning of our model or the foundation model can now be customized very easily or adapted very easily to perform any of these tasks, right? So you don't need to build a machine learning model for that particular task only, but that one foundation model is able to perform all of these tasks. And the main reason for a foundation model to behave this way is I attribute it to a couple of things. One is the transformer architecture, right? So the transformers is a kind of neural network architecture which is very efficient, it is easy to scale, and it is highly parallelizable. So you're able to take that transformer machine learning, the neural network architecture, and build this foundation model, right? And this transformer architecture can also model the interdependence between your input and the output data. So because of this new kind of transformer architecture, and also, we're taking lots of data, lot of, unlabeled data. And with that, the amount of data and how big these models are, after these models reach a certain size, because we are building bigger models now with foundation models, after these models reach that certain size, we are seeing that these models are exhibiting capabilities that we had not seen before, right? Like, for example, in context learning. So they show the potential to learn from English language that you provide as the input. In context, they are learning what the output should be, and they're generating the output, right? So that is some capabilities that we had not seen before with the smaller models, with the traditional models. And once this model reaches that critical size, we are able to see these kind of capabilities, which was not present. That's why it's become so popular, and customers are able to take that foundation model and reuse it for several different tasks. right? So that's a primer on why generative AI has become so popular and how is it different from traditional models.
So in your opinion, is that the sort of big crux change? And instead of having to have all these separate ML models, which had to be, trained and deployed for each small little task, this foundation model just opens it up that people just have a lot more choice and a lot more variety in what they can do, and they can just base it on the single foundation model and suppose get more bang for their buck.
Exactly. Yeah. So, and I'm going to talk about, everybody, like organizations would build their own models, ML models for that particular task. But now there are these foundation models that are commercially available off the shelf, and you can take the model out of the box and use it just to do your tasks. And those tasks can be any of these tasks. So that's the reason why it's become so popular and it's so versatile, right? You're able to take advantage of that. So how does a foundation model, large language model, really work? So these large language models are, because they're generative in nature, they work on predicting what the next token or what next word should be in given a sequence of words. So for example, here you see I give it the prompt, today I went to the, and now the foundation model, it's tasked to complete that sentence. Now it is looking to predict what that next word should be. And it does it through going through its vocabulary of words and figuring out which are those words that are highly probable to go into that sequence, given this sequence of words. And then it just randomly picks the most probable words. That's why you see that this is based on probability. And if you give the same prompt again to the foundation model, it can pick a completely different word the next time. So they are generative in nature and they are probabilistic in nature. And that's how, and this process is repeated until it completes the sentence or the blurb of text that it has to generate. So here's some prompts and how you can reuse the foundation model for several different use cases, right? So you can take the same foundation model and ask it to translate. So for example, here, where is the library in German is, and it completes that, it completes that in German. And I don't understand German, and I'm hoping that it's correct. So that's that. And then you can use the same foundation model to extract information. Like we're asking a question here, how tall is the Empire State Building? And it's giving me the answer from its knowledge, from what it's learned, right? And you can now use the same foundation model to even summarize documents for you. So for example, here we're asking the foundation model to summarize this legal contract into 3 bullets. So that's the instruction we are providing the foundation model, and we're giving it the legal contract as well. And now the foundation model is able to follow my instruction and also provide an abstractive summary of this legal contract, right? So one thing to note here is traditionally, the traditional ML models were good at giving me extractive summarization, but because of the versatile nature of these generative AI foundation models, they are also able to do abstractive summarization. Like, for example, it not only extracts information from the text that you give it, but it's also able to provide an abstractive summary on what it's read. So really powerful to generate new content. So the way we interact with these foundation model is through what is called prompts. And if you've seen, if you've been using foundation models and generative AI for a while now, you see that prompt engineering is very, very important to be able to get good information out of these foundation models. So a prompt is nothing but the input that goes into your language model. And these models are extremely sensitive to the way you construct these prompts, and well-crafted prompts give you good results, good outputs. And these prompts are just provide guidance to the foundation model and tell them how to respond. So for example, here the prompt I have given is the sky is, and the output is that the foundation model is completing my sentence there. So prompt engineering, as I said, is extremely important. A prompt can contain an instruction, the context that you want to provide it, what is the input data, and the output indicator, right? So that's what forms a prompt, right? And within the prompt, you can tell it, like, say, for example, extract the names of the people mentioned in this below text. And here is the output. That's the instruction I'm giving the foundation model. And I'm also telling it what is my desired format, how I want the output to be. How should the foundation model give me the output? And I want the format to be like this: people, colon, and comma separated list of people names, right? And then I'm giving it the input itself. This is the text, and I wanted to extract the people names from that text, and it gave me the output in the way that I asked it for. So this is the behavior that we are seeing. This is that in context learning that I talked about. It is able to learn with just natural language instructions that I provided, and able to provide me the answers, the outputs that I'm expecting it to. And that's why, carefully crafting this prompt is important. And it's also important for the application builders who are building generative AI applications to have prompt templates, several different prompt templates, and figure out which prompt template works best for the kind of output that they're looking for while they're building their applications. And even, having prompt templates in a prompt store or a prompt catalog, and while they're testing out, test out which prompt template works best, is generally recommended for application developers while they're developing GenAI applications. What happens when I say, okay, when I do the prompting and the prompting really doesn't work, and I'm even constructing prompts and it really doesn't work? That's when you can also give what is called a few shot prompting, meaning you can tell the large language model to give the output in a certain way by giving it a few examples. So here in the prompt, I'm saying I wanted to classify these reviews as positive or negative, but I'm also giving it a few examples of how the output should look like. And then it's able to provide the output in the way that I wanted following these examples, right? So few shot prompting can also steer the model to do better or perform better when you're not able to get prompting to work in a single shot, right? And do note that with few shot prompting, we are not training the model in any way. We're not changing the weights of the model in any way, and it's not fine tuning. It's just, giving it a few examples, and it's able to learn in context and give you the outputs. Any questions? I know I'm running super fast in all of
No, we're good. No, just, yeah. I think it's interesting so far. I'm appreciating the sort of background and understanding how some of this prompt engineering works.
Right. Yeah, certainly. All right. So that was a primer on how generative AI works and large language models. And here's the Amazon's portfolio of generative AI. So we have, the ML frameworks and infrastructure for those who want to do their own, train their own machine learning models or train their own foundation models. And we provide the frameworks through, ML frameworks and the SageMaker frameworks and Amazon EC2 instances. But bulk of us will fall into this category of, consuming the models. And for that, we have the AI service, which is a serverless service called Amazon Bedrock. And with Bedrock, we provide pre-trained foundation models. Currently, we have models available from Amazon, which is Amazon trained models, which is Titan text model, which is a text-to-text model. You provide text as the input and get text as the output. And then we also have Titan embeddings model, which when you provide text as the input, you get embeddings as the output. And embeddings are nothing but numerical representations of the inputs that you give. Say, for example, you take a sentence or a group of words, you want the embeddings model that group of words or the sentence in mathematical representation, which is basically multidimensional vectors. And because these foundation models are just doing math, right? Computers understand math. We need to convert these text into math or into numbers so that the foundation models can do the math on it and understand the interdependencies between the words, because language is complex and we want a way to model that language into numbers, and so that the foundation model is able to do computation on it and provide answers to your questions.
So for the
So
embeddings, if text is the input and then the embeddings is the output, that to me that doesn't sound particularly human readable. Is the result of the embeddings then something you would then input into something else, which would then generate something? Or have I misunderstood?
correct. You're right. The result of the embeddings is not something that would be useful to you and me as a human, right? But the embeddings output is certainly useful to store these embeddings and perform similarity search, right? For example, you take these embeddings and store in a what is called a vector database, and then once, say for example, you create embeddings for a document, for an entire document, right? And now that language in that document is converted into embeddings, and these embeddings are just numerical representations of the language, which kind of holistically capture the language within the document. And you take those embeddings and store them in a vector database. And now, when it is time for you to ask questions based on that document, or you want to summarize that document, you ask the question, you take that question, pass it through the embeddings model, and get the embeddings for the question as well, and then do a similarity search against that vector database. And because we are also passing the question through the same embeddings model, we're getting embeddings for the question, and now we can compare or do a similarity search against those original embeddings of the document, and then get semantically similar blurbs of text within that document that can help answer that question. Does that make
Okay,
sense?
so I think so. I mean, I think my understanding has been, for example, you would have a foundation model and then you would upload, say, a PDF document, which may be a legal document, it may be the homepage of your website, it may be a contract, any kind of thing. And then the Titan embeddings is going to look at the word similarities and is going to find out the words that are similar to each other. If you've got I don't know, a pet shop, for example, dog and cat is going to be really similar. It's going to see those as types of animals. You're going to have a Rottweiler and a Doberman. Those are going to be even closer word connections because they're similar types of dogs. And the way it stores that is in that vector database, which is the mathematical representation of how close these words are together. And then when you do a question, it's going to able to look into that vector database and go, give me the different types of dogs or cats or whatever. And then it's going to be able to pull the answer from the vector database because it knows what words are close to each other. And then words that are further apart, it's going to sort of ignore, I think.
Right, exactly. Yes.
Okay, I'm getting there. Maybe.
Right. So that's the use of the embeddings model. And a lot of customers are doing that because they want to provide that context to the large language model so that it can summarize the documents for them, or it can answer questions based on those documents for them. So,
So
and
a
also,
foundation model may be a foundation model that understands legal jargon, but then you're going to update your own contract, maybe in an individual contract that you've created, which you then upload, and then you can query that contract, which is going to use the foundation model to understand all the legalese of it. But then the responses are going to be particular to your document that you've just uploaded.
correct, exactly.
Okay.
Yeah. So again, Bedrock, the Bedrock service, provides you with that choice of several different foundation models, and we believe that no one model fits all use cases. So the way they are trained, these models are trained very differently. The kind of data sets they use are very different.
Okay.
The model architectures are different. So the outputs can be different. So it's always best to try out several models and figure out which model works best for your use case. And that's the reason we are bringing more and more foundation models within the Bedrock service to figure out so that you have the choice to figure out which works better and use that particular model in your generative AI application. And then, if you want to go to the SageMaker Jumpstart route, we also have some open source models and proprietary models available within SageMaker portfolio. Again, SageMaker is our machine learning platform which you can use to build and train your own machine learning model, as well as deploy that machine learning model after training, or host those machine learning models for inference, right? SageMaker Jumpstart has the difference between Amazon Bedrock and SageMaker Jumpstart is that with Bedrock, it's a serverless service, so you're consuming the foundation models through APIs. With SageMaker Jumpstart, you have a choice to take the foundation model and host it on your own infrastructure, and then consume that model within your generative AI applications.
That's good to know. I hadn't quite worked out that nuance of the SageMaker Jumpstart is in a way host your own, and then the Bedrock is just via an API.
Correct. Yeah. All right. So moving on. Why build generative AI applications on serverless compute? So if you look at the GenAI ecosystem, as I was telling earlier, most of us belong to this category of model consumers or tuners. 99% of us will belong to this category as application developers, right? We just want a pre-trained foundation model, and we just want to consume it typically via an API. In some cases, we might not be happy with the outputs and we want to fine tune the model. Again, we want to be able to customize that foundation model, take it and just fine tune very, really quickly for my own use case. So most of us will fall into that category. However, there are model builders and providers like, say, for example, Anthropic, AI21, and Cohere. All of those are, model builders or model providers who are pre-training these foundation models from scratch and heavily investing in the compute that is needed to train from scratch. Just to tell you how much of training and how much of compute is required to build a good foundation model, it takes several hundreds of GPU time and several days to build a foundation model. And experimenting with it and making sure the outputs are good, it takes weeks to build one foundation model, to train one cycle. So it's a lot of investment and effort. So how is Gen AI, integrated with serverless services? So as I said, you can use, you as a model consumer or a model tuner, you are going to build this application which is able to send in the construct the prompts at request time. Say, for example, you're building a chatbot. Your user sends in a question, and the chatbot has to answer that question. Now, as an application developer, you take that question, put it in a prompt, build that prompt at the request time, then send it to the foundation model, get the answers back, and that's the answer that is sent back to the user, right? And as a model tuner, you're taking your domain data and sending it to the existing foundation model to fine tune, and you will get a new model, fine-tuned model, and that model is what you're going to be using as a model consumer to send in your prompts and getting the outputs from that model. So why I believe serverless is the way to go to build generative AI applications is because with serverless services like Lambda and step functions and Fargate, you're able to quickly build a Gen AI application and combine it with services like Bedrock and SageMaker, and then rapidly deliver smarter applications, because time to market is the key. The generative AI space is moving very quick. And so building applications quickly and making them available to your customers is key to differentiating businesses. And so I believe that serverless provides that speed that is needed to match the speed of generative AI to build applications. All right, let's see some emerging use cases that I've seen with customers while building these generative AI applications, and what are the patterns. A lot of customers are building generative AI applications through what is through this pattern called retrieval augmented generation, wherein, and I'll talk about retrieval augmented generation more, but essentially it's taking your data, your organization specific data, and making it available to the foundation model so that you're able to answer questions based on your data, or summarize your data, and also generate abstractive content based on your data. The other use cases are, summarizing documents and things like that. So, for example, you take legal documents and send it to the large language model, and the large language model is able to summarize the legal document in easy to understand language, right? And then the other use case that we're seeing is document generation with facts, meaning you can take data from your databases and send it to the large language model and ask it to create a report, for example, based on that data from your databases. So that's a very popular use case as well. So, what is RAG? What is retrieval augmented generation? Because this is a very popular pattern that you're seeing customers build applications using. So the large language model is trained on data. Say, for example, you pick up a large language model that was trained last year in 2022. The data that it used to train is only up until 2022. So it may or may not have seen your organization specific data, which is private to your organization, right? So you want to use the power of large language models, but you want to augment its knowledge through your data. So that's why it's called retrieval augmented generation. Say, for example, you have white papers, you have financial documents, or even you have like transcripts, and you want to be able to use the power of large language model and generate content based on that. So using this retrieval augmented generation pattern, you can augment the generation using that. And this is also one way to reduce hallucination. And we've seen this if you've used large language models a bit. You've seen that sometimes these large language models lie very confidently. And that's saying it's hallucinating, right? So one way to mitigate that hallucination is to say, tell in your prompt to the large language model to, hey, answer my questions based on this content, but don't deviate from that content. Stay close to what is there in the content. And if you cannot figure out the answer, just say you don't know and don't make up your own answers, right? So that's one way to reduce the hallucinations. And as I said, these LLMs are static. The data that they've used is static. So if you want to provide it more recent data, then this is one approach to augment its generation. All right, so I know I spoke a lot, so let's go to the demo where I can show you a RAG-based serverless chatbot that we built using serverless services and Amazon Bedrock and SageMaker. And as Julian, as you said, these RAG engines, which are essentially vector databases that hold all of the embeddings generated for the documents. So essentially, this is a chatbot application that uses API Gateway and CloudFront for hosting the static application. And then it uses a serverless backend, essentially AWS Lambda functions for the compute, and DynamoDB to store metadata and relevant content, and then SNS for notifications, and step functions to ingest these documents into these RAG engines so that they can be the embeddings for these documents can be created and then stored in the RAG engines. And I think Julian will provide you a link to this.
Yes.
This architecture has been open sourced, and you can this and deploy using a CDK template
So yeah, I
today.
have put it in the chat, so you should be able to copy and paste it. But yeah, it's also on the screen if you need that. So yeah, it's all on GitHub, available to, you can do it all yourself.
Awesome, thank you. All right, so I will next go to this demo here. So this is that chatbot essentially that I just showed you the architecture. So this is a GenAI based chatbot where you have the flexibility to use either Bedrock or SageMaker or any third-party models as well. And it also supports this retrieval augmented generation, and you have the choice to use Amazon Aurora with PG vector extension, or OpenSearch vector search as a vector database, or even Amazon Kendra. And Amazon Kendra is an intelligent search service that is powered by machine learning again. So again, that you can use any of these data sources as your retrieval augmented generation data source, and use the models to start chatting away with these models, right? So let's go to the playground. It provides you a playground, right? So I can pick up whatever model that is being instantiated. Here I have a variety of models from Amazon Bedrock. I'm going to pick up the Claude V2 model. And first, I'll show you without a RAG data source. Like I'm chatting directly with the foundation model here, right? Say, for example, I'm going to ask it what use cases can I implement with Amazon Bedrock, right? Hopefully you're able to see that. I'll make it a little bigger.
So Vera, when you're picking the model, is that just a research thing you do to find out what Claude does and Claude V2 does, and what it's good or not necessarily bad at, but what the best model is? And is this one of the things with Bedrock that it's so easy to use all the different models that you can sort of send the same prompt to a whole bunch of different models and then get the reply and then sort of work out which one's the best for your use case?
Yes, so that's the real cool part about Bedrock is that using the same API, you can switch the underlying foundation model, meaning you send in the same invoke model API to Bedrock and as a parameter to that API, you send which model I want to use, and then it uses that particular foundation model to generate the output. And each model is different in the way it gives you the answers. Some models are more descriptive, some models are more concise. So depending on your use case and the kind of language that you want for your generative AI application, testing out with several different models, and figuring out which works
Okay.
best is key to developing an application, generative AI application. And that's why Bedrock makes it so easy, because with one API you can test out all of these models.
Okay. So here you've then got, so this is using no RAG, so it's no customizable information, and it basically says, I don't know anything about what you're asking.
It doesn't know, because when the model was trained, Amazon Bedrock was not yet available, and so it does not know about Bedrock, and that's why it said, I don't know. So what I did was I used let's see here, workspace. So I created what is called a workspace within this application. And within that workspace, I took the Bedrock user guide, the public documentation of Bedrock, which is available now, uploaded it, and used the Titan embeddings model and created embeddings for this entire PDF document, which is the Bedrock user guide, right? And now when I ask the question again, so let's go back to the chatbot, and now I'm going to use that workspace, and I'm going to, because now it's using that the document that I provided it, it should have some information about Bedrock. So I'm going to ask the same question: what use cases can I use Bedrock for? So now it should have some more information and context. And so it should give me an answer.
Cool. There we
because
go.
I augmented, the model did not know about Bedrock, and then gave it information about Bedrock, and now it's able to give me a good answer. I'm going to show you how the prompts are constructed in this application so that you get an idea of how retrieval augmented generation really works. So this is a GitHub repo, and specifically, if you go to this Python code here, so here are the prompts. So you're taking that user question or the input from the user and telling the large language model, here's the prompt I'm constructing. As a human, you're saying this is a friendly conversation between human and an AI. If the AI does not know the answer, it truthfully says it does not know. And you're giving it the current conversation and the next question and the assistant, right? Um, and Right, and here's where we are doing the retrieval augmented, prompt, constructing the augmented prompt. So using the following pieces of context to answer the question at the end. If you do not know the answer, just say you do not know, don't try to make up an answer, right? So that's what we are giving the instructions, and we are providing the context here. And this context is coming from my Bedrock user guide, which I provided, right?
Okay.
And I'm giving it the context, and I'm telling the large language model to use this context to answer this question. And now the LLM is able to answer my question using that context that I provided.
Yeah, so that actual prompt engineering, and it's so important because it's not just asking your question, but it's also setting all the around kind of information. I mean, in this example, he's saying basically, here's the PDF document that I've uploaded to generate the information from. Don't lie to me, and be kind. I think what are the things, a nice answer or that kind of thing. Because yeah, you've got to be as explicit as you can be in asking a question to get the kind of answers you want. It's just a
Exactly.
machine. I mean, even though this is artificial intelligence, it's just a machine. You need to be very clear on your expectations, and then you're going to get a
Yes.
better.
Yeah, sometimes it's like you have to treat the large language model as a kid. You have to be explicit
Yeah,
in
that's
your
what I was thinking. Yeah.
instructions. You have to be explicit in your instructions, and even when you're explicit, sometimes it does not behave the way you want it to behave. So try different ways to prompt the large language model to behave the way you want it to behave, very much like
Yeah.
a little kid.
We're going to be training our kids. We're going to be thinking of our kids as large language models in the future and trying to interact with them in the same way. That's going to be chaotic, but it could be fun. I like it. Just Nelson Assis, thanks for joining us via YouTube. You said because I know in the architecture diagram there was something about Kendra for this demo. Is that being used somewhere here, or?
So you have the choice to use Kendra, but I have not used Kendra in this demo. I've just
Okay.
used the Titan embeddings model to create the embeddings for the entire user guide, and then store those embeddings in OpenSearch, and then use the cosine similarity to find the relevant pieces of information when I ask the question, and then send that context to the large language model, and the
Okay.
large language model is giving me an answer.
Okay, Vida, we've probably got like sort of 2 or 3 minutes before we need to wrap up. What else do you think is useful to show? And yeah, Nelson replies, OpenSearch, cool. I think it's cool too.
Yeah, so let me see if we can generate some embeddings here. So as you can see here, this particular application also shows you how you can use the embeddings to find out how similar these sentences are. So I have few input sentences here. The dog chases the ball. A canine runs after a spherical object is input one and input two. And if you can see here, we generated embeddings for these, and then we're doing the cosine similarity between these sentences. And you can see between input one and one, you get a one as the cosine similarity because they are the same sentences.
Same, yeah.
point 7 is the similarity score between input 1 and 2, which is kind of, a canine runs after a spherical object, which is close to what dog chases the ball. And if you see input 3 is point
Much
4,
less, yeah.
yeah, much less, right? And if you see input
Animal.
4 in automobile is parked in the garage, it's even lesser, right? And the vehicle is stationary in a covered parking area, which is also lesser to input 1. So this gives you an idea of how important embeddings are in and how embeddings are able to model the interdependencies in the language and able to tell you that, hey, these two sentences are very similar and input 1 and 4 are not very similar, right? So, and that's how we are able to get that similarity results, and then we take these context and then provide it to a large language model, and now the large language model is able to give me a good summary. And you can ask the question, hey, I can take the entire document and send it to the large language model, but the large language model has limitations in terms of how many words it can process at a time. That's why we need to follow this approach.
Okay, so yeah, so this is a really good, I suppose, demo application. It is all on GitHub. Where was the link? So yeah, that's the link that Vida has been showing. And this just looks a good way with your playground to be able to explore how you can consume the different modules, how you can use the RAGs to add information. And then, yeah, it's interesting just to learn about the AI ML and understand how the embeddings works by looking at basically the number figures to see how close the words are aligned. Cool. And then I think just before we go, there is also another workshop, which some of our other team have put together, which is super cool. And so, yeah, this is a whole workshop that has been released, I think, even yesterday or the day before. So really brand new, using GenAI and AWS for diverse content types. So part of what Vida was talking about is, there's also text and images and a whole bunch of different kind of things. So, yeah, that's also a sort of self-paced workshop that you can go through and you can, just explore a bit more about the whole GenAI world. There was a question also, thanks so much for joining us, Raython, via Twitch. Is there a way I can see this presentation for referencing later? Is the session being recorded? It is being recorded. As soon as that's finished, it'll be basically published on the youtube.com/serverless land. And yeah, the GitHub links are already, in fact, in the session notes. So it'll be able to see it for your viewing pleasure later on. And just before we say goodbye to Vida, next week, same time, same place, we're going to be talking about visually building AWS applications. So Carl and Paris are going to be looking at new features of actually App Composer, if you haven't used a whole different way to build apps, which is super cool. And what else did we have just before we say goodbye? Serverlessland.com, all the things for serverless on AWS. Super cool. Don't forget EDA Day. It'll be super cool if you came on Thursday. Vida and I will both be there and we'd love to chat to you. And don't forget reInvent coming up also at the end of the year. Also another super cool time to be able to see you as well. So yeah, thanks so much for joining us here on Serverless Office Hours. Really appreciate you taking the time. I do have to do Dorky RSA. I was in Serverless Days Cape Town. So nice to have seen you over there. And thanks for joining Office Hours. Really appreciate it. And Retha, yeah, thanks for the good feedback. It's been nice to have you along. But most important, Vida, thanks so much for you joining us today and telling us all about generative AI. I'm glad I could get some of my questions answered as I start to figure out all this GenAI kind of stuff. And yeah, really appreciate all the hard work you've been doing to put this all together and explain how it all works. So thank you very much.
Thank you. Thanks for having me, Julian.
Excellent. Well, thanks so much, everyone, for joining us on Office Hours, and especially Vida for helping us out.